Okay, so good afternoon, everyone. So we are going to start a new topic today, which is basically escape velocity and Kepler's law. Okay, so we'll study about escape velocity, about different orbits, right, of satellites, and then we talk about escape velocity. What is escape velocity? What is the value of escape velocity? I hope all of you have covered the previous topics. Tell me, everyone. Yes. So till now we studied about gravitational force, gravitational field, right? Gravitational potential energy and gravitational potential. And we have solved all the problems based on that, the basic problems. So all of you understood those concepts? Please let me know. Tell me, guys. Tell me, all of you have understood all those concepts? Yes or no? I'm audible, right? I think I'm audible. Okay, very good. So we will start with a small revision session. Okay, so we will have a small recall test. Let's see, right? I hope all of you can answer these questions clearly. Okay, so we have first question, which is gravitational force between two bodies varies dash with respect with the square of the distance between them. Easy? Tell me, guys, easy? Yes, very good, Samya, very good, Chulika, very good, Karishma, easy, very good. Okay. Very good, Sanya. Second one, guys. The value of the gravitational constant G is, the value of gravitational constant G is 6.67 × 10⁻⁹ Newton meter square per kg square. Okay. 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 Very good. Third one, gravitational field at a point. Okay. A is E. The force experienced by mass m when it is placed at point m is, very good, right? Yes, most of you are saying correct answer. I'm getting some incorrect answer also. Just see the definition, right? Force, okay, and gravitational field, okay. That is based on definition, right? Gravitational field is force per unit mass, okay. Force per unit mass, right? Now, fourth one, the value of gravitational field inside uniform spherical shell. Tell me, inside uniform spherical shell. Very good. Yes. Yes, everyone. Correct. Right? Most of you are correct. Fifth one. The sun is at the center of the solar system and all planets are orbiting around it according to the dash model of universe. So this is just a theory, right? You just have to remember. Okay. I haven't studied this, but we just have to remember the answer is heliocentric, right? Okay. This is just a theory that you might have studied in school. Okay. Okay. So we have covered what is gravitational potential energy already, right? So let's see one concept test based on that. Tell me. Tell me, guys, what is the answer of this? Is it still in Newton's law of motion? Seriously? That is fourth chapter. I'm just thinking what will happen to other students. Anyways, Okay, so I'm getting some answers. A. Okay, C also. This is very interesting question based on the concept, right? That's why it's concept test. Think about it is basic definition, basic definition. Everyone think. Anjali, Anjali is here. Tulip, Anamika. I got, okay. So I got 2A, 2B, 2C. Okay. What about others? Think about it. See, this is a concept test. Just think about the basic. What is the basic definition of potential, right? What is the basic definition of potential? What is the formula of potential? Tell me. Think about it. Right? Let's see the answer. The answer is C. Okay. Right? The answer is C. Because potential energy is between two particles. Yes or no? Tell me, yes or no? It is Gm1, M2 by R, right, everyone? Right? So obviously, right, whenever you talk about the change in potential energy, it will be of both the objects, na? Think about it, right? So the answer is C. Yes or no? Yes or no? Force as well as energy are for this system. Potential and field is because of one object, right? It is clearly evident from the formula, right? Okay. Now gravitational potential. Tell me the answer of this. Easy question. Think about it, guys. Okay, and we might have a bit longer class till 6. I'll give a break in between. Okay, 5-10 minutes break because we need to finish this topic today. Okay, and then we will have a doubt solving session, right? Okay, so two masses of 1 kg and 4 kg are moved from point A to B under the influence of field due to ring of mass capital M. During this process, the change in potential is, now think about it, think about it. What's the formula of change in potential? Tell me. Tell me, guys. Potential formula is V is equal to, yes or no? Tell me, yes or no? Think about it, yes or no? I'm not talking about the this, because here it is changed, right? So this is the value. Now, what is this M? Tell me, what is this M? Which, right? This M is which one? This capital M or 1 kg or 4 kg? Think about it. Think about it. See, what is the definition? What is the definition? V is equal to E into L. Yes or no? Yes or no? Think about it, very basic, right? And E is depending on just this mass, not the mass 1 kg or 4 kg, right? That's what I said, right? That's what I said. Electric field and potential are because of the object which is creating the field, right? Okay, so let's see the answer. C. Got it? Because it doesn't matter what mass you are bringing, right? It is the potential of that point because of mass capital M, right, everyone? Tell me. Got it? Think about it. Got it? Okay, very good, everyone. So see, those who attended DSS session, right, or those who couldn't attend, but please watch the videos. We have already discussed around 80% of HC Verma, this gravitation chapter, right? Okay, we have discussed all the type of questions which is there, okay, from potential, force, field, and potential energy, right, everyone? So I hope all of you are able to solve these kind of problems now, right? How many of you are solving DC Pandey? Tell me, guys, how many of you are solving DC Pandey? Are you able to solve? Tell me, are you able to solve? Are you finding the problems easy now? Yes, very good, Samarth. What about others, NEET students? You have clarity in concept, right? What is being asked, what you have to do. Okay, okay, very good. Okay, that's good, right? Everyone, those who have any doubt, please message the group itself. There are many people to solve. Okay, okay. So let's start today's lecture, okay, which will be mostly about gravitation, sorry, orbits, okay, the orbits in which satellite revolves, then what is escape velocity, and then Kepler's law. Okay, now before that, right, we have to understand, right, when we talk about gravitation, so this is one of the most important forces which helps or which keeps our universe together, right, everyone? Okay, when we talk about stars, sun, right, moon, earth, all are there in the place because of this force which is gravitation. Okay, and we are talking about classical mechanics, so do not ask question like quantum mechanics or gravitation is a distortion in space-time continuum and all those things, right? We're just talking about Newtonian physics, okay, in which gravitation is a force, okay, by the virtue of mass and distance. So I can say that how this force, how this gravitational force, right, keep universe together. Okay, so when we talk about Earth, just take example of Earth, right? So I can say that Earth revolves around Sun. Yes or no? Tell me, yes or no? Right? Okay, and Earth revolves around the sun due to gravitational attraction of the sun. So we are going on planetary level. There is a mass which is Earth and there's a mass which is sun. And because of that, because of two different masses separated at distance r, right, sun will exert the gravitational force on Earth, right, as well as all the other planets. Right, everyone? Right? Okay. Because of this, right, they will revolve around the sun. Now, ideally, you should think, or what we have studied in our junior classes, that planets revolve around the sun in circular orbit, right? But it doesn't happen. Okay, it's not the actual case. In reality, the planets revolve around sun in elliptical path, right, everyone? In elliptical path. Okay, right? This is the observation that we have observed, that the planets revolve around the sun in elliptical path, okay, with two different axes, which is minor axis and major axis. Now, when we talk about ellipse, I hope all of you know what is ellipse. Ellipse will look like this, okay. So I'll just give you a brief idea about ellipse. So ellipse is your flattened, right, circle, right? Just push the circle in one direction, okay. So it's a flattened circle. Now, when you talk about this flattened circle, right, we have this distance between two extreme ends and this distance between these two extreme ends. Okay, so this bigger distance is called as major axis. This is called as major axis. Major axis. And the smaller one is called as minor axis. Minor axis. Okay, right? And this is obviously center. Now, when we talk about this ellipse, we have 2 points. We have 2 points, this point and this point. Okay, these 2 points are called as focus. These 2 points are called as focus, right? So by the definition, right, by the definition of this, okay, right, by the definition of ellipse, what I did, I just took any point on this ellipse. Okay, suppose I took this point on the ellipse, this point on ellipse. Then the definition says that, the definition of ellipse say that the distance between, suppose this is F1 and this is F2, right? The distance, right, of the point, of any point on the ellipse from focus F1 and F2 are always same. Suppose this is L1 and this is L2, right? So L1 plus L2 is constant. Okay, so this is about the ellipse. Okay, right? Why we studied this? Because we should know what is ellipse, what is focus for Kepler's law. Okay, right, everyone? So I hope all of you understood this. Somehow it's not constant, it keep on changing, right? But obviously for our convenience, we take the average distance. Okay. L1 plus L2 is constant, right? L1 plus L2 is constant. Okay. Okay. Now, what about satellites? So we know that as planets revolve around the sun, satellites also revolve around either Earth or any planetary object. Yes or no? Tell me, yes or no, right? And they should, or yes, they should revolve in a specific orbit, right? They should revolve in a specific orbit. Okay, that is, obviously there are different type of orbits, geostationary orbit, right? Okay, we will talk about those. But we know what are satellites. Okay, satellites are basically man-made instruments which is revolving around Earth or any other planet, okay, in a specific orbit, right? Okay, now see, when we talk about whatever we talk about the distance between Earth and Sun, right? It is average. Okay, it is average, right, everyone? Okay, and when we talk about two objects, we just talk about the force between two objects. We do not consider the force or the perturbations or the changes because all the other objects. For example, if I'm talking about Earth and Sun, if I'm talking about Earth and Sun, the distance between Earth and Sun, right? I will be focused between Earth and Sun only. I need not to worry about other planets or moons and all those things. So these are the assumptions that we make while doing calculations, okay, at our level, right? Okay. Now the force, the formula of force would be same, which is Gmm by r square. It's not going to change. Okay. Now we know that. Just think about it. How many of you? Wait, I'll just use a blank. Wait, I'll just use a blank sheet. Just give me a minute. How many of you have heard, like, seen this cannonball? Tell me. I hope all of you have seen cannonball, right? Right, everyone? At least in TV, not in real life, at least in TV. Okay, so how does this cannonball looks like? Or in Hindi, we used to call it a top. Okay, right? So there was an interesting video. I'll just send you the video later, right? I'll just explain you what happens. Now, suppose we have a cannonball. Suppose I'll just draw Earth. Okay, so suppose we have Earth. Where is Earth? Okay, so suppose this is one big Earth, right? One big Earth. Okay, so this is Earth, right? Okay, now this is elliptical. I was not supposed to. Okay, this is not Earth. Wait. Okay, this is one big Earth, right? Now suppose we have a cannonball over here, right? Suppose we have a small cannonball or a small cannon, right? A small cannon. Okay, and you fire it, right? Or you just keep at any angle and you fire it. What will happen, right? It will go like this, yes or no? I'll just make a small diagram over here, right? Because since the Earth is so big, okay, we feel that the surface of Earth is flat. Okay, so we have a cannonball over here, and if we fire it, it will follow a parabolic path and fell somewhere, right? Okay. No, Karishma, it is a cannonball, right? My drawing is awesome. That's why it looks like car. I don't know why. This is cannonball. Okay. So if you fire it with certain velocity, it will follow parabolic path, yes or no? Tell me, yes or no, right? Okay. So suppose this is the distance at some velocity. Suppose this is the distance at some velocity v. Now you increase the velocity. You increase the velocity, right? Then it will go like this. Think about it, right? Further increase the velocity, it will go like this. Okay, further increase the velocity, it will go like this. Okay, now further increase the velocity. So if you further increase the velocity, it should go like this. Okay, right? Now suppose you further increase the velocity. Okay, I'll further increase the velocity. Then it will go like this. Now there's no other space to fall, so it will keep on falling. Tell me, it will keep on falling because the gravitational force is always, right, pulling this object toward it, right? So it will keep on falling. Yes or no? It will keep on falling. Think about it, right? Since it is keep on falling. So what do you think? What will happen now? Tell me, what will happen now? If it is keep on falling, right? If it, right? If this cannonball will keep on falling, what will happen? Don't you think that it will never ever fall on Earth? It will start revolving, right? In a fixed orbit. Think about it. Yes or no? Yes or no? Yes? Okay. So can I say that, okay, so if I throw anything with enough velocity, if enough velocity, it will go like this. But is it always the case, right? Is it always the case? Suppose we throw it like with more velocity, what will happen? Again, right, the same thing that happens to all the object. It will go like this. Yes or no? Right? It might just leave the Earth's surface. It might just go to any other place, right? That happens to all the satellites which go on other missions, right? Mars mission or any other mission. Okay, so obviously that should be the obvious question. If we increase the velocity further, it will not revolve around the Earth in a fixed orbit. It will just escape the Earth's surface. Yes or no? Think about it. Yes or no? Makes sense, no? Makes sense, right? And what is this velocity? So I can say that, okay, this is the minimum velocity for this velocity. Suppose this velocity which is used, right, by the cannonball, okay, to revolve around the Earth, right? This is the minimum velocity which is required so that this cannonball will not fall on Earth, okay, right? So I can say that this v velocity is the minimum velocity, right? Minimum velocity at which, right, or maximum velocity, okay, you can just say in whatever term, I can say that it's the minimum velocity which is required so that the cannonball or any object will not fall on Earth's surface again, right? Or it will keep on revolving around the Earth's surface in a fixed orbit, right? And this velocity is called as escape velocity. Okay, got it, everyone? Tell me, got it? Right? I hope all of you understood what's the meaning of escape velocity. Clear? Okay. So You can ask, what if I throw something which is like which have speed more than escape velocity? Obviously, it will just leave the Earth's surface, right? Okay. And what if I throw something which is having velocity which is less than escape velocity? It will fall down on Earth. As simple as that. Okay. Got it? Right? Okay. So I hope all of you understood this concept. Very good. Okay. Right. Okay. So let's see one thing. So I hope all of you know what is the, yes, what is gravitational force, what is centripetal force, what is centrifugal force. We know that mass of all the objects are different, right? So obviously the gravity, right, gravitational force will be different on different planets. Okay, so see this. So what is the force when we talk about any object which is moving or revolving in circle, right? This is something that we have already studied in, tell me, already studied in atomic structure, right? That if I'm having any object which is revolving around something, okay, it must have two type of forces. Yes or no? Tell me. It must have two type of forces. One force which is pulling it toward itself, right? Okay, and the second force which is pushing it away from this object. Okay, that's why it is maintaining its circular position. Now, in atomic structure, we talk about electrons revolving around the nucleus, and the two forces were electrostatic force and centrifugal force. Right? Right? I hope all of you remember this. Now, don't you think that we should have the same type of concepts? Okay, when we talk about revolution of any object around any object, right? So suppose we have an object, or just suppose Earth, okay, right? Or any satellite which is revolving around the Earth, okay? So the satellite is revolving around Earth with some velocity, and by the virtue of that velocity, it should have some centrifugal force. So I can say that centrifugal or centripetal force, right, is gm by r square, and it should be equal to centrifugal force, which is mv square by r, right, is equal to gmm by r square. Okay, right? So this v naught is the velocity, at which it should revolve. Yes or no? Tell me, yes or no? Okay, right? Now we know that g, yes, so we know that gm, right, gm by r, right, is gm by r square is nothing but, tell me, small g. Okay, this mm is cancelled, by the way. This mm is cancelled. There's a mistake. It is not here, right? This is a mistake. Okay, it is just capital G into capital M by R, because mm is cancelled, right? And this RR will be cancelled. So I can say that V naught is equal to under root of capital GM by R. And by the definition, we know that acceleration due to gravity is GM by R square. Yes, yes, moon, everything which is revolving around the earth or any other planet is due to gravity. So it is root gr. Anyone have any issue? V naught is root gr. So this is the velocity which any object is having if it is rotating around any other object. Okay, right, right. Okay. Now suppose you increase the distance. So obviously, if you increase the distance, this r will increase, right? Okay. So if you increase the distance, you will have the same formula, right? The only thing which will increase changes this. Yes or no? Tell me. Yes or no? Tell me, guys, because in that case, the formula is mv square by r plus h is equal to g capital M small m by r plus h whole square. Small m cancel, right? This will cancel. Okay, so we will have v is equal to root of gm by r plus h. Okay. Okay, very good. So these are some basic term which we already know, but I'm just revising it. Okay. Now I hope all of you know what is angular speed. Tell me. I hope all of you know what is angular speed. It is the rate of change of angle, right? Rate of change of angle with respect to time, or rate of change of angle, that itself means with respect to time. Okay. So if, and this is equal to omega. Omega is equal to what? R cross V or V cross R? Tell me. R cross V or V cross R? This is one concept which students like tends to get confused in. Tell me. See, I already got two answers. I know this, right? Because this is something which students get confused in. This is certainly wrong, right? Okay, this is certainly wrong. See this formula, na? Right? Okay, guys, think this is certainly wrong. Because it is given that omega is equal to V naught by R. So how can I write it? Right? V is equal to, tell me, V is equal to R cross omega or omega cross R? Now that's the question. That should be the only question. Yes, that's why I got some wrong answers. I still got some wrong answers. That's the thing. That's why I keep saying revise, revise, revise. No, I'm saying cross. Omega, obviously we know omega, but it is R cross omega, R cross omega, or omega cross R. Or just R omega. Because R is also vector, omega is also vector. So obviously there should be cross product, right? That's the basic concept. Okay, this is basically omega cross R. Okay, this is basically omega cross R. Okay, please try to remember these concepts. Okay, try to remember these concepts. These are very, very small concepts that will lead to some mistakes in exam. Okay, that's why I keep saying revision is the key, right? See how small concept I asked. Okay, so anyways, this is omega cross R. So if it is 90°, this is just omega R. Now omega is equal to V naught by R. So I can just replace this V naught from here, yes or no? I can just replace this V naught from here. So if you replace, we will get omega is equal to square root of Gm by R plus H whole cube. Okay, right everyone? Tell me, anyone have any issues till this point? Anyone have any issue till this point? I just substituted the value of V naught in omega. I didn't do anything else. Samya, Anjali, anyone? Is it clear? Okay, very good, right? Okay, very good, everyone. So angular momentum, what will be the angular momentum of Earth satellite? See, I'm just revising the concept that we have already studied, okay? So I expect you guys to answer me. Samya, see, it is, so V naught was root of Gm by R, and omega is V naught by R, right? So if this R will go inside the square root, it will become R square into R is R cube, okay? Got it? That's why we have Gm by R cube. Okay, so we know that angular momentum. So angular momentum is given by MVR. So this is the formula, right? Time period of revolution. We know 2 pi by omega. Omega we already know. Now, if you see this, square to both sides, I'll just use this somewhere, right? So we will get what? T square is equal to 4 pi squared r cube by gm. Yes or no? Tell me, yes or no? Yes or no? Right? I'll use this concept. Okay, I'll use this concept somewhere. Okay, so I can say that T squared is directly proportional to r cube. Okay, where T is the time period of revolution and r is radius, right? Okay, very good, guys. Okay, now see, with whatever we have studied for two objects, it can be used for planets, right? It is not necessary that there should be any change. Okay, it can be used for planets. Okay, so we know that when we talk about the energy between two objects, it is gm1 m2 by r, right? In the same way, the energy between two planets or between planets and satellites will be same, right? Which is gm1 m2 by r. Okay, the kinetic energy, potential energy, everything would be same, right? Everyone, tell me, right? So when you talk about the potential energy between planet and satellite, suppose Earth and satellite, it will be given by same formula. Okay, right? And total kinetic energy of system. So we assume because when one object is rotating around other object, right? We assume that this object is at rest. Yes or no? Think about it. Yes or no? At rest means statistically rest. I'm not saying that it will rotate or not, right? Its position is not changing, right? So I'm just expecting that stationary, right? This is at rest at its point, okay? And this is moving. Okay, so the total energy, right, or kinetic energy is half mv square, which is half m omega square r square. Yes or no? Yes or no? Right? And we know that omega is equal to what? Tell me. Omega is equal to, tell me, G capital M by R cube. We just saw this. Right? Right? Yes or no? Yes or no? Now, do you remember that we have studied something like this somewhere? We have already studied something like this somewhere. Okay, so I can say that omega square r square is equal to square gm by r cube into, sorry, small r cube into r square. So it will be r. So this relationship we got from here, this formula. If you're wondering from where we got this relationship, so this is by the basic definition of omega. Okay, now if you just replace this in this equation, right, you will get k is equal to g m1 m2 by 2r, or capital M small m by 2r. So can you observe potential energy is minus g mm by r, kinetic energy is equal to half of g m1 m or capital M by r. What about total energy? Tell me, total energy is equal to minus g capital M small m by 2r. Yes or no? Tell me, yes or no? Now, have we studied the same thing somewhere? If you remember, have we studied the same thing somewhere in atomic structure? That kinetic energy is half of the potential energy or negative of potential energy. Does it ring bell? Right? So isn't it exactly the same as what we have studied, the relationship between total energy, kinetic energy, potential energy in atomic structure, right? So I hope all of you can understand this relationship, where total energy is always sum of kinetic energy plus potential energy, which is actually half of potential energy. Okay, right? Right, everyone? Got this concept? Tell me, yes or no? Okay, very good, everyone. So this is the graph. Okay, this is the graph of potential energy. Okay, okay. Now Yes, so we talked about the satellites. So we have different type of satellites. So here we are talking about geostationary satellites. What's the meaning of geostationary satellites? Tell me. Suppose you are here. Suppose you are here on the earth and someone is watching you. Someone is watching you, right? Okay, right? Now, suppose if earth is rotating, obviously you will move. If this satellite will move in the same speed, right? Will it be always above you? Think about it. Will it be always above you? Right? And should it rotate with the same, right, with the same direction as of the earth, with same time interval or same time period, right? And that type of satellites are called as geostationary satellite. Geo, location, stationary, rest. So I can say that, I hope all of you understood this, right, with this example. Okay, so I can say that if the satellite appears to be stationary with any point, right, or when seen from earth, then it is called as geostationary satellite. Okay, and since it should be stationary with respect to any point on earth, right, it should have same time period, it should revolve in the same direction as the rotation of earth, which is west to east, right? It must rotate about the same axis of the earth. Okay, and it must be circular, right? Everyone, tell me, right? Understood these concepts? Yes or no? Yes or no? Okay, now if it is rotating, so I can say that these two, yes, so these two are not geostationary satellites. Okay, so this is your geostationary orbit. Okay, now we don't have to do a lot of deep analysis of these satellites. Don't worry about that. Okay, now when we talk about this, the satellite will be at height h from the earth's surface. The satellites will be at the height h from the earth's surface. So when we talk about the distance of the satellite from the center of the earth, it should be r plus h, right? It should be r plus h. Okay, yes, yes. And if we use the same concept that we have used just now, okay, use the same concept. So can I say that? Right? If the time period is same, right? If the force is same, what the force is same, okay? So what is the force? Tell me. Mv square by r is same as G capital M small m by r plus h whole square. Agree? Right? Yes or no? Tell me guys, yes or no? Now, this mm will get cancelled, and we know that v square r is omega square into r is equal to G capital M. Here it is r plus h, by the way, sorry, my bad. So r plus h, I'm writing as small r plus h, I'm writing as small r. Okay, just for the simplification. So omega squared will be given as G capital M by R cube. That we have already proved, right? That we have already proved, so we need not to prove it again, we just write it directly. So if you, yeah, if you consider this, so it is 2 pi by t, omega is 2 pi by t, right? Whole square is equal to this, right? Okay, right? So why we calculated? Because we know what is the time period of the Earth, okay? We know what is mass of Earth, we know G. We want to find what height should be of geostationary orbit, okay? We want to know the height of geostationary orbit. So we'll put all the values of radius of Earth, G, M, T. We will get approximately 36,000 kilometer. Means if we have to keep any satellite in geostationary orbit, it should be around 36,000 kilometer above Earth's surface. Yes or no? Tell me yes or no, guys. Right? Got it? Okay. Okay. Very good. Next, escape velocity. Okay. So I hope all of you understood already escape velocity. Don't worry, Samarth, I'm recording the lecture. You can just watch the video afterwards. Okay. But try to attend as much as possible. So we already said that if a particle, right, is, yes, right, if a particle is given sufficient kinetic energy, as we said in the example of cannonball, okay, if it is given sufficient kinetic energy, then it will escape, or it will negate the attractive force of Earth. Yes or no? Tell me, yes or no, right? And it may escape the Earth gravitational pull, right? Now this velocity is called as escape velocity, right everyone? This velocity is called as escape velocity, right? Right? Okay, we have already discussed this. Now let's talk about mathematical expression for this. Now okay, yeah. Now we know that when we talk about uh, getting away from Earth gravitational force, what is the meaning of this? Tell me. Tell me. Means Earth should not have any effect on that particle. Yes or no? Yes or no? Tell me, guys. Think about it and let me know. Right? If I'm talking about, right? If I'm talking about escaping the Earth's surface, it means Earth should not have any effect on that object. Right? So I can say that. I can say that the net potential, your net energy, okay, net energy after, right, after leaving the Earth's surface should be zero. Okay, so we have delta U plus, sorry, Ui plus Ki should be equal to Uf plus Kf. We already know that. Okay, and it is like projectile, as the cannonball, as the example of cannonball, it should escape the Earth's surface, means it should reach infinity. Now infinity is not the distance, infinity is just a distance at which any object will not have its effect. Yes or no? Tell me. That's the definition of infinity. We have already discussed this, right? Okay, so I can say that the final kinetic energy and final potential energy should be zero in this case. Yes or no, guys? Tell me. It should be zero in this case. Everyone is getting this concept? Yes or no? Please respond, guys. Please respond. Anagha, Akshaya. Okay. Are you getting this concept? Why it should be zero? Ask yourself. Do not just accept what I'm saying. Okay. Right? So I can say that if initial kinetic energy was half mv square, and this is the velocity which, right, which is given to the object, right, when it is thrown from the surface of the Earth, plus, now minus again convention r, now this should be equal to 0. So if you solve this, you will get, if you solve this, you will get this. Okay, right? Okay, sorry, we will get half m v squared is equal to g mm by r. Now this m and this m will get cancelled because this is the mass of the object which is thrown, right? So v square will become 2gm by r, or v is equal to root 2g by m. Sorry, 2g by r, 2gm by r. Okay, right? I hope all of you know this, or it is v is equal to root 2gr? Yes or no? Tell me yes or no. Okay, so this is your escape velocity. Okay. Okay, so now let's think about the factors, right? When you talk about the factors, on which factor this escape velocity depends. So see, this is quite easy. We know that it depends on two things. First, the attractive force by the earth. Yes or no? Tell me. Yes or no? Right? And second, the velocity. Agree? Agree? Now, if you see the formula, just see the formula. Now, if you see the formula, it is V is equal to root 2gr or root 2g capital M by R. Now, it is quite evident from the formula that it is not depending on the mass of the object, right? Irrespective of mass, be it 1 kg, be it 100 grams or 1000 grams. The escape velocity would be same for all the objects, right? Okay. And it depends on M and R. What is M? M is the mass of the planet, right? M is the mass of the planet and R is the radius of the planet, right? And again, position will matter. Okay. Okay. So I hope all of you understood these concepts. Tell me, all of you understood these concepts? What, how, Samya? See, think about it now. Suppose if it's something is kept over here, it is thrown vertically, right? Okay. And suppose something is kept over here and is thrown something like this point, like this, right? So obviously, in this case, V, right? Yeah, sorry. So yes, so I can say that in this case, there might be some changes, right? Because we know that the gravity G due to Earth's surface varies from position to position. Yes or no? Think about it. Yes or no? Right? The G itself changes from position to position. Okay? So obviously position matters, na? Right? G at equator is not same as G at pole. Okay? Okay. So I hope all of you understood this escape velocity. All of you understood escape velocity? Yes or no? Tell me, guys. Okay? Okay. So see, these are the different forms. This is the form, right? In terms of mass, this is in terms of G, right? And this is in terms of density. So I have already derived these two. This you can derive, yes or no? Tell me, this you can derive. Just replace mass with density, you will get this relationship, okay? Right? Okay. So I hope all of you understood these questions. Sorry, these concepts. Anyone have any doubt in these concepts? Okay, very good. So let's try one small problem. Okay, there might be one small problem. Just try to solve these problems, guys. Try to solve this problem. Try to find the formula. Try to find the guys. See, first of all, this problem is based on work energy, as simple as that, right? Okay, so what we have, a spaceship is launched into a circular orbit close to Earth's surface. Okay, what additional speed, right, should now be imparted to spaceship so that orbit to overcome the gravitational pull of the Earth? Okay, okay. So we know that if I talk about the kinetic energy, tell me what would be the kinetic energy? Yes, we have already calculated the kinetic energy, right? You didn't have to calculate, right? Because mass is not given, nothing is given. You just have to write in terms of G, M, R, okay? So we know that kinetic energy is equal to half of potential energy. Yes or no? Tell me, yes or no? Yes or no? So kinetic energy is G M1 by R, step by step, right? Okay. Right? Yes. Yeah, you can just calculate that also, right? We have already calculated. Now, what is the escape velocity? Tell me, what is the escape velocity? It is root 2gr. Yes. And what is the velocity? Yes. What is the velocity for? Yes. What is the velocity of any satellite which is revolving around the Earth in an orbit? We have calculated that also. It is root gr. Simple. Yes or no? Tell me. We have calculated both of them. So this is your escape velocity, and this is the velocity of satellite which is moving around the Earth's surface in a circular orbit. Yes or no? We not. Tell me. Yes or no? Right? Now, what you are asked to find? Additional speed now. So additional speed is VE minus V naught. As simple as that. Now tell me, was it a difficult problem? Tell me about this. Was it a difficult problem? Think about it. Because this is escape velocity, right? And this is the velocity which is required to, tell me, this spaceship to overcome the gravitational pull. And this is the velocity, right? In which it is launched into this orbit, right? Got it? Got it, everyone? So here they have used the basic formula of kinetic energy, but you can just calculate because we already know what is escape velocity, which is root 2gr. And we already know what is the velocity when an object is revolving in a circular orbit, which is root gr. So difference will give you the change in speed. Okay. Okay. Very good, everyone. Right. Okay. So there are some problems that we will discuss. Okay. Okay. So let's take 5 minutes break. Okay. Let's take 5 minutes break, or yeah, let's take five minutes break. Okay, everyone. Recording. Yeah. Yeah, so according to Kepler's first law, I can say that all the planets which revolve around the sun, okay, it will do so in an elliptical path with sun at the focus, one of the focus, okay, right, everyone? Just this much, just this theory, nothing else, okay. The next is law of areas, right? Now suppose when talk about a planet, right? Suppose we have Earth, okay? At some day, suppose today is 19th of October, okay? 19th of October, okay? So 19th of October till 29th of October, it will cover some area, yes or no? Tell me, yes or no, right? So suppose this is the area covered. In how many days? 10 days, okay? Right? Now, suppose we talk about 10 July to 20 July. Even though the orbits are different, even though the distance between sun and the planets are different, right? Even though it looks like the area will be different, but if we're talking about same time interval, okay, if we're talking about same time interval, which means here also 10 days and here also 10 days, Then the area swept by, right? Area swept by the planet, okay, with, tell me, sun at the center, okay, with sun at the center, sun at the focus will be same, means this area A1 should be equal to this area A2. Okay, this is also a theory. Okay, you can just prove it, but this is the theory which is say that the line joining any planet, it is written also, a line joining any planets to sun sweep out equal area in equal interval of time. Got it? I hope this is quite easy to understand. Yes. Okay, now when you talk about the area, we know that area is this. Suppose we talk about this, right? We will consider sun as uniform mass distribution. Okay, we won't be considering sun as non-uniform mass distribution. Okay. Okay. Now, when you talk about the area per unit time, okay, basically this is, see, there are many factors which affect the motion. Okay, this is many factors. It's not just the sun. There are other planets also, right? That's why when we talk about geostationary orbit and when we talked about root gr as the velocity of any satellite in a given orbit, we assume that the force of other planets is not affecting the motion of the satellite, right? Tell me. Okay, but here it's not the case, right? It is the actual path. I'm talking about the actual path, and that will be affected by other planets. That's why it won't be circular. If it would have been just earth and sun, then I could have said, okay, it would be circular, right? Got it? Okay. Okay, so this is what I was talking about. Now when we talk about two time intervals, be it this or this, okay, this or this, the area would be same. Now if the area is same, what do you think? I can say that in this position the speed would be more, yes or no, as compared to this, yes or no, right? And you can just think out logically, because if it has to move in this orbit, right, the centrifugal force should be greater because the distance is less, so the gravitational force is more. Okay, and the gravitational force is more, you should have more centrifugal force to overcome this gravitational force. And more centrifugal force means you should have more velocity at this point. Okay, right? So I can say that, okay, intuitively it makes sense that the area should be same. Okay, right, everyone? Understood? Now, when you talk about some mathematical formulas, so we know that we want to find, or we are saying that dA by dt is same, right? Or delta A by delta t is same. Okay, so what is dA by dt? Now we know that dA by dt is basically half r delta t. R delta t is this, r delta theta is this distance into this. Tell me yes or no. Area will be this now, because this is a very small section I'm considering. I'm considering very small section, right? So if I'm considering very small section, it would be almost, it would almost look like a, right? So half r delta theta into r by delta t. Okay, right? Or you can just say this one, r into r square delta theta by delta t, and we know that delta theta by delta t is nothing but omega. So this is half r square omega. So can I say that if this r is less, omega will increase. Okay, that's what I said, that when the distance is less, the satellite will move faster or the planet will move faster. Okay, it will have more velocity. Right, everyone? Okay. Okay. The last is law of period. The last is law of periods, which I said, okay, that's, or which I've already proved, that square of period of any planet, okay, about the sun is proportional to cube of semi-major axis. Okay, so see, this I have proved for circular orbit. Yes or no? Tell me. This I have proved for circular orbit, right? So I'm just, yes. So Kepler just generalized this. Okay, sorry. Okay, so Kepler just generalized this for elliptical orbits. Okay, so we have already proved that when we talk about Earth and the satellite, okay, Earth and the satellite, we proved that omega was what? Omega was root of gm by r cube. Okay, and using omega is equal to 2 pi by t, okay, we proved that t square is directly proportional to r cube. Okay, right? Okay, everyone. So, so when we talk about, yes, when we talk about derivation, so obviously we derived using a special case, which is a circular orbit. So he observed this, right? We can derive this for circular orbits only, right? We cannot derive for the elliptical orbits for, like, according to us, because it will include lots of mathematical calculations. So we will take the simple case, we will take the special case of circle only, because what is an ellipse? When you talk about ellipse, ellipse is basically a flattened circle, right? Ellipse is basically a flattened circle in which both major axis and minor axis are equal. Okay, right? So if it is, so Kepler Kepler derived the formula for this special case, and he observed other parameters, he observed the other values for different orbits, and he observed that this relationship holds true. Okay, the parameters, the constants might change, but this relationship will hold true for all the orbits. Okay, right? So we just have to focus on this, nothing else. Okay, right, everyone? Because they have done the same thing that we have done. Okay, t square is directly to r cube by taking as a spherical axis as a special case. That's it. And minor axis, major axis, I've already told you what is minor axis, what is major axis, right? Okay. Anyone have any doubt till this point? Sorry, Kepler's law is just theory. Okay, sorry. Sorry, I'm saying sorry all the time. The Kepler's law is just theory. So you just have to remember the statements of Kepler's law, nothing more than that. See, if you want for ellipse, I will just post you the steps. I can do that, but it is of no use, because even for ellipse, even you talk about ellipse, okay, using the second law, the rate of change of area is same, we can prove, okay, but still the answer would be same. Okay, so I will just post it in the group, or I'll just include this in our PPT, right? But I won't be doing it, I won't be driving it in the class because it's useless, it has nothing to do. You just have to know that the last relationship, t squared is equal to 4 pi r square by gm. Okay, that is given into r cube holds true for both circular case or elliptical case. Okay. Okay, everyone, got this? Tell me. Let me check what else is left, because for there's one more thing, but I'm not sure that if it is there in syllabus or not. Let me check. And in next class, we'll be discussing problems, all the problems of HC-VAMA. Okay, all the problems of HC-VAMA, the remaining problems also, right? And module, okay, till question number 7 in all the questions, right? In question number, in class 1.8.1, in class 8.1, till question number 7. Okay, homework you can solve till 11. Homework till 11. Try at least. Okay, try 11. Okay, 8.1 in class till 7. Everyone have to do 8.2 homework. Sorry, 8.1 homework till 11. 8.2. 8.2 is comparatively easy. You can solve. Okay. So 8.2 in class. Till question was 6. In class till question was 6. Right, everyone? And homework till question number 6. Okay, so till question number 6, just attempt. Okay, just attempt. Sorry guys, I just muted this. Okay, if you can't solve, it's fine, but just try to attempt. Okay, and DC Pandey, whatever doubts you will have in DC Pandey, we will clear all the doubts in DC Pandey. Okay, bye everyone. Thank you. Bye everyone.